Project 2.5, an embedded ATmega328P. In this project, we'll be talking about how an ATmega328P circuit can be embedded into a solderable perma-proto design. In essence, we are essentially creating a permanent circuit. The first thing I'd like to discuss and touch upon is how a circuit should work in this scenario. It's essentially a reflection of the previous project, Project 2.4, which discussed about how an ATmega328P chip can be a standalone chip without its Arduino base. As you can see here, there's voltage regulation, a reset button, an AVR ISP programmer header, and a crystal oscillator. And our job was essentially to create systems for this ATmega328P so that these specific functions that it requires will actually function with the chip and will be able to work in the simplest way. That's why we use capacitors here, and I've actually added a diode. And I'd also like to talk about how this voltage regulator works, because I've talked about it in the previous video, but I feel it's a very important thing to touch upon in the digital world. So I'm using a 9-volt battery, as you can see, for this video. And this voltage regulator converts it into 5, which is really useful because in the digital world, you want 5 volts. Next, I'd like to discuss my soldering process. So first, I'd like to show the bottom of my circuit. So the bottom is kind of a representation of what's actually going on in the circuit. And also, you can see that I've cut my wires in a certain way that they kind of work around each other, but they do make the most of space. And you can see right here, there's these little scratchy marks, and those are traces. Those have been cut to be able to reduce the amount of connections and rows. You can see all these rows are all connected by copper or whichever metal they are. And this is like a simple explanation of how these actually work and are applied. Is basically, if you see this voltage regulator right here, it's not supposed to be directly connected to this ATmega328P chip. However, it looks like it is. In reality, there's traces cut underneath that disconnect the two components. And lastly, I'd just like to talk about my experience with soldering. So soldering in this project has been very confusing because my circuit doesn't actually function at full entire capacity. As you can see here, that's potentiometer all the way up. So the original VU meter, all LEDs will be turned on when the potentiometer is in the state, essentially when it's impacting the circuit with its highest amount of resistance. However, for some reason, the greatest, or the LED 10 and LED 1 simply do not illuminate, and I'm not 100% understanding of why the circuit actually does this. But from my understanding, it's simply just a soldering mistake, because solder is in fact 300 degrees Celsius when you're melting that metal, and perhaps a part was damaged. So this project basically taught me about the precariousness of engineering, and that how you have to be careful, like essentially why we put this chip seed in, not to fry the chip. All in all, though, I really enjoyed this project because it allowed me to apply knowledge from previous assignments like the standalone ATmega328P with soldering, which we use in projects like the traffic light and other assignments. Thank you.